Okay, so this is for question 2, the three-petal rose, or rosé. So first we want to start off by determining if it's sine or cosine when solving this problem. This particular rosé is sine, and we can tell because it falls on the pi over 2 axis. So that axis right there. That's the axis of symmetry. So that is sine, and we'll just plug that right into our equation here. So now we've got r equals a sine b theta. And we're going to need to calculate these other values. So what is a for this equation? The a value is how far out the petals extend to a maximum. So all three of these petals will fall in the same r value. That's the distance away from the pole. That is 4. So the a value for this particular function is 4. But wait a minute, why is it negative 4? Isn't this graph facing upwards? Well, that's because the normal sine function graph actually has this first petal fall downwards. It's very unusual, not what you'd expect, but that's just how it works with sine functions. However, not all odd petal number sine functions will fall downwards. If a is equal to 5, it would actually fall upwards. So that's just a particular quirk with the sine function. That's just how it works. Gonna have to accept it. So let's plug in that a value here. We have r equals negative 4 sine b theta, leaving us with just b to solve for. So what is b? Well, this is an odd number of petals on the rosé. So b is just the amount of petals, which is 3. And that leaves us with the full equation, r equals negative 4 sine 3 theta, once you've plugged in b. So that's all for the three-petal rosé, and thank you.